location inside the table. After a reset, done by clicking the site logo, views will automatically switch to fit the table to the width of your browser. The search box at top right accepts symbols, names, atomic numbers, or advanced expressions. Selecting the box dims the table to prepare to show matches. If I enter 111, you can see it first shows hydrogen, then sodium, then Roentgenium. Or, if I type the letter K, all elements with the letter K in their name highlight. Potassium appears in the close-up area as it's an exact match for that symbol. Click elsewhere to exit search mode, which works in any tab or view. More on advanced searching later. Search works in the dozens of languages Ptable is available in and accepts input in those languages. The Latin translation is helpful for determining the origin of symbols. The first tab offers write-ups from different sources and pops up descriptions of any element, group, period, or series. The window can be moved or closed. It can also tear off to open a new window, or dock at the edges, depending on whether you block pop-ups. The table can be further manipulated while the write-up window is open. In addition to Wikipedia, the Write-Up tab offers descriptions from Web Elements, Theodore Gray's photocentric site, the University of Nottingham's periodic table of videos, and the Royal Society of Chemistry's podcasts. Ptable will hide its series colors and mimic the color schemes of the various sites to indicate where clicks will go. A multi-purpose slider is just above the nonmetals. In the first tab, it defaults to 273 Kelvin, the equivalent of 0 degrees Celsius, STP. Element symbols are colored black if that element is solid at the selected temperature, blue if it is a liquid, and red if it is a gas. As we adjust the slider, element symbols will change color to indicate their state of matter at that temperature. To make the states more obvious, hovering over the legend will color their background instead of symbol. The mouse wheel also manipulates the slider. Let's move on to the Properties tab. The property name is shown on the left and value on the right. In this tab, clicks lock an element in place rather than open a window. Click the locked element to release and return to hover mode, or click another to stay in locked mode. Beneath the close-up view, we have an abbreviated form of the full electron configuration. More on this in the Orbitals tab. The first dataset is series. Notice that where the slider was before, we can now choose series classifications. You can see the hierarchy. Tabs change the data shown here, and selections here change the slider area. In the Properties tab, atomic weights in the table are replaced with whatever dataset we select. The State dataset changes the slider back to a temperature slider and behaves similarly to the slider on the first tab. Melting and boiling point are more interesting. The darkness of an element's background color indicates how far away its melting or boiling point is from the selected temperature. Here we can see that neon's boiling point is much colder than 2000 Kelvin, and osmium's is much hotter, whereas thallium's is just a little colder, and indium's just a little hotter. As with all datasets, each element's boiling point is shown in the Properties area, as well as in the atomic weight area. Electronegativity has no subset, so the slider area disappears. Elements are colored in proportion to their electronegativity, with yellow being very low values, and orange being higher values. Electron affinity and valence work the same way. Ionization energy is similar, but also has a slider showing the values for the first 30 ionization levels for all elements. The next half dozen properties have subsets that can be chosen in the slider area. We can easily see that atomic radius increases with period, but decreases with group. I'll just click through the remainder of the properties. Abundance is interesting. Here we can see the universe is 75% hydrogen by mass, and the oceans are 11% hydrogen and 86% oxygen. The discovered slider shows the year's elements were isolated. Sliding back from this year dims the elements that were not yet discovered at the time. You can also search for numeric expressions or ranges in any tab or view. Say you need to find the element with an atomic weight of about 200. Mercury. Under Properties, let's find the elements with a covalent radius of 100 to 120 picometers. Or find all the elements that boil at greater than 5000 Celsius. Or all the elements with a valence of 2. The Orbitals tab centers on properties which derive from the atom's electron arrangement. Clicks in this tab also lock elements, rather than opening any windows. Instead of series being colored, the S, P, D, and F blocks are colored, and helium moves next to hydrogen to join the S block. In place of atomic weight, common oxidation states are shown. All oxidation states are visible beneath the close-up, with the most common in bold. Elements' full electron configurations are shown in order of energy level in the slider area, and an orbital diagram is filled with this data. The highest energy level orbital is highlighted in yellow, and a 3D diagram of just that orbital is shown, as well as its L, M, and N quantum numbers. Hovering over the grid also allows viewing of the related 3D model. The Isotopes tab contains data on almost 4,000 isotopes. Now, atomic weight is replaced with the number of isotopes of each element. Here, click Spawn Isotopes of that element. By default, only selected isotopes are shown. Choose All from the sliders area to spawn all known isotopes. Similar to the Properties tab, the table will update with details on each isotope. Selecting each property will color the isotopes in proportion